Today's factoring lesson is going to be on factoring trinomials that have the form x squared plus bx plus c. So these are a lot of fun, so get excited. So before we start factoring our trinomials, the x squared plus bx plus c, we want to think about how do we get trinomials that have that form, x squared plus bx plus c. You guys have actually seen this before in our previous chapter, so let me just remind you how we get trinomials that look like that. You don't need to write this down, but you should be listening. So here's my message for those of you that don't listen when I tell you you need to listen to the videos. So we have a binomial times a binomial. If you guys remember, when we're multiplying binomials, we're going to FOIL this out. So FOIL first, outside, inside, last. We're going to FOIL 4 times and then combine any like terms for our final answer. So first thing we're going to do is multiply the first terms. And again, FOILing is just like distributing, so keep that in mind. We're going to distribute the x, so here's our x times x. That's going to give us x squared. Then we're going to do x times a positive 3, so that's plus 3x. 6 times x plus 6x. And then 6 times 3 is plus 18. So hopefully you guys kind of remember doing that in the last chapter. I think we've had a couple of review questions on some assignments with that. So here's our 4 terms. We're looking for any like terms to combine. So we have these x's in the middle, this 3x plus 6x, and our final answer is x squared plus 9x plus 18. Okay, so what we want to kind of think about here is when you're going to be asked to factor trinomials, you are going to be given this x squared plus 9x plus 18. And what we have to figure out is how to get this answer right here. This is what our factored answer looks like when we factor our trinomials that have the form x squared plus bx plus c. So what we need to think about is, well, we know our answer should look like this. Where did this x squared come from right here? And if we remember, that came from multiplying the x's together. So we can conclude that we're going to have an x here and an x here, because if I were to multiply this out, I can always multiply it out to check my answer. This x times x is going to give me this x squared. Where did this 18 come from on the end? So the 18 came from multiplying the 6 times the 3 right here. So we would ask ourselves, all right, I know that what goes in the second spot of our binomials has to multiply to 18. Well, you have some options for what multiplies to 18. If we think about our factor pairs, it could be 1 and 18, it could be 2 and 9, it could be 6 and 3. So of those options, how do we know which ones it should be? Because all of those multiply to 18. So to figure out the only factor pair that works out, what we do is we say, well, I know that we have to end up with this 9x right here. Like, where did the 9x come from? And if you look straight above, the 9x came from the 3x plus the 6x. So where did the 3x come from? 3 times the x up here. Where did the 6x come from? 6 times that x. So basically, whatever numbers we put right here are going to end up with our x's for multiplying it out, and we know they have to add up to this 9x. So if you look at your factor pairs, 1 and 18, is 1 plus 18 equal to 9x? No. Or just, you can think, is it equal to 9? Is 2 plus 9 equal to 9? No. Is 3 plus 6 equal to 9? And that's the pair that works. So we're going to say x plus 6 and x plus 3. And this is going to be the answer. This is our factored answer. So it's almost like we're foiling backwards, if that makes sense at all. We have to figure out, if we're given the trinomial, how do we get this factored answer? All right, so I know I was kind of babbling a little bit on that last slide. So let's just get into some examples and you can see the pattern of how we factor our trinomials. So we're going to factor this trinomial, x squared plus 12x plus 20. So when we factor trinomials, our answers are going to look like this. We need two binomials that would multiply out to give us x squared plus 12x plus 20. So here's the thinking that we do. We know that what goes in the first spot right here, so the f of our FOIL has to multiply to x squared. So what multiplies to x squared? X times x. And we know that what goes in our last spot right here, the L of FOIL, has to multiply to a positive 20. So you have options. What multiplies to positive 20? So think about your factor pairs. 1 and 20, 2 and 10, 4 and 5. So how do we know which factor pair it's going to be? That's where we have to make sure that the outside and the inside terms of foiling will add up to give us a 12x. So of those factor pairs, do any of those add up to 12? 1 plus 20 is 21, 4 plus 5 is 9, but 2 plus 10 is 12. So we're going to say plus 2 and plus 10. One thing I want to point out is, let's say you had factored this and you wrote, you wrote the x plus 10 first and the x plus 2 second. Those are the same answers because when we factor the trinomial, our factored answer is two binomials multiplied together. Multiplication is commutative, so the order doesn't matter as long as you have the positive 2 and the positive 10. Here's what you're going to do to show me that you have thought through your answer and that this is correct. You are going to, this is our little check that we're going to do. You're going to say, so first of all, we know that the x times the x gives you the x squared, right? We know that the 10 times the 2 gives you the plus 20. So how are we getting that 12 in the middle? So you're going to say, all right, I know that x times 2 is 2x, and I know that 10 times x is 10x, and 2x plus 10x is that 12x. So that's how you're going to show that you checked right here. And I'll show you that again on the next page. Okay, so these trinomials will start to factor faster the more we get used to those. So on the last slide we saw we were looking for factors of C that add up to B. So what's going to be a little bit trickier here is we're going to throw in some negatives and find a way to deal with these negatives, but still looking for factors of C that add up to B. So our C value is negative 24. So we want to consider factors of negative 24. I'm going to start with just factors of 24. We have 1 and 24, 2 and 12, that's a 2, 3 and 8, 4 and 6. Now I know that to get a negative 24, when I multiply factor pairs together, I need one positive and one negative factor. So the question is, should it be a negative 1 or should it be a negative 24? Should it be a negative 2 or a negative 12? I could think through every possibility till I come up with the one that's going to add up to our B value, but we can get there a little bit faster by just knowing a couple of tricks about how these work. Whatever your B value is, positive or negative, so see how we have a positive 2? The larger factor pair will have the same sign. So if you make sure that your larger factors within each pair are matching the sign of your B value, then we're going to get to that factor pair we need much faster. So that means that we want the larger factors to be positive, so I'm going to make all the smaller factors in each pair negative. Now I'm going to look at all these pairs. I'm looking for the pair that adds up to positive 2, and I see we've got a negative 4, positive 6, and we are going to x minus 4, x plus 6. We're going to write it into the two binomials. This is how we factor the trinomial. Now in the last slide, I was showing you how we're going to just show to me, like you're going to communicate your thinking, that you're double checking that this is the right answer. What that can look like. So first of all, we know that this x times this x gives you that x squared. We know that negative 4 times 6 gives you this negative 24. So I'm going to trust that you have already sorted that part out. The thing we need to make sure is, how do I know that of all these factor pairs, you picked the pair that's adding up to the positive 2? So all you do is you are going to check your outside and your inside terms. You also can, so we're going to multiply. You can do them both below if this seems a little bit easier because they're just closer to each other. And now I'm going to look and say, all right, is negative 4x plus 6x positive 2? It is, so check. I know that we got the correct factored answer right here, and I have shown the check. That's just, I'm showing my thinking on it. Okay, so next example, factors of C that add up to B in these trinomials where your A value, this is our A value right here, is just a 1. Get excited for the next lesson when we start putting numbers in front of the x squared. Another thing you want to make sure you're looking out for is, do you have a GCF? I know we talk about this in class. It doesn't come up in the videos as often. So is there a GCF we can factor out of the trinomial? That's always our first step of factoring. In this example, there's not a GCF we can factor out. So now we will go to factors of C that add up to B. And here's our B value, negative 6. So I'm going to start with factors of 27, 1 and 27, 3 and 9, and those are the only ones. And then I'm going to make sure that my larger factors have the same sign as my B value. Because the B value is negative, I'm just going to go ahead and make these negative. Now I'm looking for the pair that adds up to negative 6. And we've got a 3 and a negative 9. So we go ahead and we write this into our binomials. Oops, there we go. We know it's going to start with an x and an x because those are going to multiply to give us the x squared. And then we said positive 3 and negative 9. That's how we get that negative 27. And then we're just going to do a quick check. So you say, look, Mrs. Youngberg, I know how to make sure I got the right answer. 3 times x is 3x. X times negative 9 is negative 9x. Do those add up to the negative 6x in the middle? And they do, so I know that this is the factored answer we're looking for. Okay, so to summarize the factoring rules with the positives and the negatives, if your C value is positive, that means when you multiply two numbers together to get a positive C value, your two factor pairs will have the same sign. It's either a positive number times a positive number, or it's a negative number times a negative number. Those are the only ways to get a positive C value. Now, how do you know if you want positive factors or negative factors? Your factor pairs, and by the way, these are factor pairs right here. Here's the smaller factor, a positive number, the larger factor, a positive number, smaller factor, negative number, smaller factor, negative number. How do you know if you want the positive factors or the negative factors? Your factor pairs will have the same sign as your B value. So if your B value is positive, you want all the positive factors. If your B value is negative, you want all the negative factors. But first, we have to see what is the sign of your C value. If your C value is negative, this is what we just talked about on the last slide. Your factor pairs will have opposite signs. So you're going to have a positive and a negative, or you could have a negative and then a positive. So how do you know if the smaller factor is positive, larger factor negative, smaller factor negative, larger factor positive? So the larger factor will have the same sign as your B value. That's what I showed you on the last slide. So just putting that into words a little bit for you as we move forward with our factoring examples. All right, two last examples here in the intro video. I'm guessing this is getting kind of long, so sorry about that. But that's okay, because we love math. Right? Of course. Okay, so factor each trinomial. this is the x squared plus bx plus c. So when you factor trinomials, we're trying to find what two binomials multiply to give us that. The x times the x is how we're getting the x squared. And then what is going to multiply to give us 32? So we think about our factors of 32. We have 1 and 32, 2 and 16, 4 and 8. And we're trying to find a factor pair that's going to add up to 12. Now let's talk about those rules for the signs for a minute. So 32 is positive, so that means, how do we get a positive answer when we multiply? Positive 1 times positive 32 is 32. So all your factors are positive, or they could all be negative. If I had a negative 1 and a negative 32, that would still give us a positive 32. So how do you know if you want positive factors or negative factors? That depends on what the b value is. Because the b value is also positive, that means that these have to add up to a positive number, so we just want positive factors. So which ones do we want? Or which ones are going to add up to that 12? Hopefully you guys are already saying, oh, that's going to be a positive 4 and a positive 8. So there's our answer, but remember, you guys are going to show me a little check. It's just you communicating, yes, I thought through this, I know this is the right answer. You're going to say, because we have to make sure that we really pick the numbers that will give us the 12x. So you'll say, all right, x times 8 is 8x. Ooh. And 4 times x is 4x. And in your head, you're saying, is 8x plus 4x equal to that 12x? And yes, it is, so check. We're done. We got the right answer. All right, last one here, we have a trinomial, x squared plus bx plus c. So we are trying to find the binomials that will multiply to give us that. Have you caught on to what's going in the first spot? X times x is how we're getting the x squared. Now we have to figure out how to get that negative 36. So that's a negative c value, so we're going to be able to talk about the signs on this one. First, let's go ahead and list our factors of negative 36. Well, I'm going to list them of 36, and I'll talk about the negatives in a second. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. So this one has a lot of factor pairs. Because they're multiplying to a negative 36, that means that in each factor pair you need one negative number. So what's going to be negative? Is it going to be the small factors that are negative, or is it going to be the big factors that are negative? And that all depends on your b value. Your b value is negative, so the factoring rules with the signs, your larger factors have to match the sign of your b value. So because your b value is negative, I'm going to make all the larger factors negative. Again, once you get used to those rules, it just gets you to the answer so much faster. So it's a way for us to be efficient once we have those rules down. All right, so of those, do any of these add up to a negative 9? We can go through, cross off the ones that don't work. We'll get to 3 and negative 12. So that's our magic factor pair, a positive 3 and a negative 12. And you're going to check your answer by showing me that, yes, I thought through, and I know that we're getting to that negative 9. So x times negative 12 is negative 12x, and 3 times x is 3x. Is negative 12x plus 3x 9x? It is, so we got the right answer.